Great. Thanks, guys. Hi, I'm Greg, lead engineer for Bob, the Hybrid L2. I've got a quick pitch deck together for like the general overview of what Bob is, what our vision is, and how we're going to accomplish that. I'll get a bit into some of the tech with BitVM. I'll also be attending the Six Synced and Resura events this week, so a bit more onto the ZK side, which I won't touch on here, but if you have any questions, I'll stick around for a bit and we can discuss. No. Cool. So the general pitch, why we love Bitcoin, it's massive. There's a lot of liquidity, untapped potential there, and you can see compared to Solana and Ethereum, there's a lot we can do with that. Oh, no. Cool. Thank you. Yeah, Ethereum's like super great, strong on tech, super lots to love about it, but TVL is very minimal compared to Bitcoin, and we can utilize that to do some pretty interesting stuff. Ethereum tech-wise, we have a lot of cool tech that we can use, like NFTs, ZK, of course, a lot of that is used on Ethereum, and all this cool stuff, and lots of cool stuff being done. But with Bitcoin, we don't have the same adoption yet in terms of tech. We've seen over the last year the rise of the Bitcoin layer 2 due to BitVM, and this is where we can really unlock the potential of those users. But Bitcoin L2s face a few challenges. Security being one, we can see with traditional bridges right now with TBTC, WBTC, the centralization risks and things that prevent adoption from custodians institutions. The other problem with Bitcoin layer 2s as they stand is the ecosystem. So going back to my slide before with Ethereum, of course, we have a lot of native degens and users who are actively using DeFi. These people don't exist on Bitcoin, or at least they don't do the same things because they can't. There's no smart contracting. And then liquidity, of course, a lot of users on Ethereum, we have a lack of liquidity, but also on Bitcoin, people, like there's nothing they can do with their Bitcoin right now. There's very few ways to earn on your Bitcoin unless we go into Babylon, which I will touch on in a bit. So this is why we had this vision with Bob to bootstrap the hybrid L2. We have both Bitcoin security and kind of best-in-class technology via the EVM, similar to like Starkware and a few of these other toolkits. We will have native BTC liquidity via a BitVM2 bridge, which is mostly trustless. I can go into the trust assumptions later when I discuss BitVM. But we can think of it like a native bridge with Ethereum rollups where there's very minimal overhead. Yeah, that's fine. So to give kind of a high level, the hybrid architecture, we basically are settling on both chains effectively, or rather, I should say, we're settling on Ethereum, but we're using Bitcoin for finality and security. So the high level is Bob is this rollup in between the two. We will have the native depositing withdrawals directly to Ethereum, which we have now. We're anchoring to Bitcoin via a security mechanism I will discuss in a few slides related to Babylon, but we achieve security through Bitcoin, and that's verified on Ethereum. So Ethereum users are satisfied because they are directly rolling up to Ethereum, but they gain Bitcoin finality, so Bitcoin users are happy. And we get the flow of liquidity in as well. So Bob, we launched a year ago. One of the largest op superchains, so we have native compatibility with, for example, Base and Optimism, only coming third in TVL after those two. So we can see the vision coming to life where we're bringing Ethereum liquidity, but specifically related to Bitcoin assets, and I think that's hopefully going to grow over the coming months as we finalize some of the tech. Then this is where I now want to get into the roadmap of how we've approached this. I've mentioned that we're live now, so I can take a step-by-step what we have done and what we're doing. So we launched in, I think, May of last year as an OpStack rollup, so it's a vanilla OpStack rollup. We're DA on Ethereum, so Bob blocks are produced via that. 2-second block times. We have, I don't think this is true, but we have, due to us being the OpStack, we would have ETH fraud proofs to ensure the security. I think we're pre-fraud proof because we're planning to replace that mechanism. But nevertheless, we could, if we chose to go in that direction, we could do that. What we also kind of focus on, our vision with this over the last year has just been onboarding a lot of Bitcoin assets. And what we can also offer is this platform called Bob Stake, or previously known as Bob Gateway. And it was a way to onboard users. So one of our biggest things we wanted to tackle with Bob was not only the vision of bringing a Bitcoin rollup to life, or a hybrid Bitcoin rollup, but also to have an easier way for users to bring their liquidity from Bitcoin into Bob in the meantime before we had BitVM finalized. And what Bob Stake is effectively is an atomic cross-chain swap. It's based on a Bitcoin intents protocol we developed in-house, where users intend to wrap their Bitcoin into one of these available assets, such as WBC, TBC, and FBTC. They are just atomic swap onto Bob, and this technology we call Bob Stake is an additional layer within the intents protocol that allows users to do more interesting things. This is where Babylon has started coming recently. So we're planning to be one of the first supported BVSs through Babylon. So what we've seen the most liquidity on our chain just now is from users depositing, for example, WBTC in Bitcoin LSTs such as solvebtc.bbn. The entity wraps this, restakes it stakes it into Babylon, and provides users of the holders of those LSTs with stake. So we can see here there's a really nice UX here where users through Bob Stake, they send a Bitcoin transaction. It technically leaves their wallet to an Ethereum wallet, but one Bitcoin transaction through the intents protocol, and they can basically earn on their Bitcoin with very minimal overhead. Soon we will have the other way round, where then they can very quickly, with a single Bitcoin transaction, go in the reverse way, and they're not constrained just to Bob. They can take that cross-chain or back to Bitcoin. What we're working on now is like the cool side of the tech. So I mentioned BitVM a few times. And this is a really hot topic. As I said, hopefully joining a few panels this week on ZK to kind of go a bit more into depth. But how we're looking to do it is the hybrid narrative is, so we'll keep the rollup on Ethereum. So our DA will stay on Ethereum. We will keep using the standard bridge that comes out of the box, but we will change the security a little bit. So what will happen, instead of the proposed doing like fraud proofs like Optimism Base would do, we would instead go a Validium way. So we would have ZK proofs check the validity of Bob, and we can use that same finality to secure the BitVM bridge. In a few slides, I can give a quick overview how BitVM works and what the architecture is there. But let's just say we will bring in Babylon. Eventually, we're going to become a BVS. They will secure Bob blocks through Bitcoin staking, verify that on their chain. We will pinpoint that to Bitcoin and have this like kind of a three-way sort of loop in the security there. Over the next year or so, we will expand out. So we're looking into different ways to have, for example, DA on Bitcoin, so we can transition to a more native Bitcoin rollup. Other ways to secure that via finality, and then extending the Bob Stake protocol. So now I can give maybe a quick rundown of how BitVM works. If you're not familiar, so what happens ultimately, you see on the far left, there's some program that checks some proof. What this looks like in the sense of Bob, how we want to prove finality, is this ZKVM application will check. So in the fully fledged version, we will have a white paper out soon. It will check that there's a Babylon-like client, so a Tendermint-like client, Cosmos-like client, that iterates over the Babylon blocks. It verifies that they have checkpointed the Bob state correctly. It will then have a light client over the Bob blocks themselves to check the Bob itself was constructed correctly, and then indexed correctly to Babylon. And there's a step on top of this as well. We will also have a Bitcoin-like client. So we will check headers so what happens in Babylon is every epoch they checkpoint their state to Bitcoin. And why we need to do this in BitVM is due to some constraints on the security, because BitVM is actually a stateless mechanism. So there's no way to update. Once you've like bridged your Bitcoin in, there's no way to update that. So to ensure security, we have the proof of work in there from Bitcoin that Babylon has checkpointed to make it very hard to break. So then that's the sort of the far left. We have this three-way light client. We're checking over Babylon state, Bob state, and Bitcoin state. So we have a three-way light client. In the zkV application, we give all these headers and blocks as input, verify that, and then output true if we're good. So that's converted into a non-interactive succinct proof there, gross16 in the case of BitVM we use. And that's split up into some Bitcoin script, which we can then execute on Bitcoin. This is the novel innovation with BitVM that was developed. Cool. And then, sorry, back one more slide. Yes, and then just to finalize that, the whole BitVM process is optimistic. It's very expensive to set up, it's very expensive to dispute. But how the plan is for that is to do like an optimistic, optimistic assumptions. So when you set up a BitVM instance, you kind of you lock in to an operator set. These are like a 1 of n honesty assumption. So this is the security I mentioned earlier, why it's better than, for example, TBTC and, well, for sure, WBTC. So one of these operators any of the operators, if on pegout there's an incorrect claim made. So for example, say I bridged my Bob BTC to Bob, I held that on Bob, and I now want to bring it back to Bitcoin. With this construction, the optimistic assumption I should say is that I can bridge it back, or that one of the operators funds me out of pocket. If one of the operators was malicious and said, hey, I actually didn't give that user their money, but I want the money locked in the BitVM instance. So it's basically like when you peg in, you just lock the BTC until it can be proved that it can be unlocked. If they provide an invalid proof, one of the other operators, any one of the other operators, this is where the honesty assumption comes in again, they can prove that was invalid with, well, if the malicious operator wanted to incorrectly peg out something, they would have to give an invalid proof, because there's only one way you can satisfy a ZK circuit with a valid input that satisfies the constraints. And if you give an incorrect proof, we play this little bisection game where you give the part in the subprogram of the ZK proof where it went wrong. And if that happens, then the operator's collateral is burned, and they don't get the BitVM. That stays locked until one of the other honest operators can peg out. So there's a few more steps involved in that, but that's the long and short of it. You bridge Bitcoin, converts into Bob BTC, and it can only be unlocked when a certain number of constraints are satisfied. Next slide, please. And then I want to go back to this Bitcoin Intense protocol I was just discussing before. This is called Bob Stake, Bob Gateway. This is kind of looping into this flywheel effect we have with Babylon now. So I mentioned Babylon are BVSing us, so they're validating our security. And what they take there is this revenue fee share from our sequencer. So our sequencer is the L2. We take ETH fees from users who transact on our chain. We provide that back to Babylon. That's fair. Then obviously those are incentives for users to then deposit more Bitcoin in Babylon. They wrap those into LSTs that then live on Bob. And those are circulated in DEXs and lending and other DeFi activities, which in turn generate more revenue fee share. So we've got a really, I think, quite a nice construction here with Babylon and utilizing those for finality. Next slide. And then Bob Stake. This is where we have this UX Intense protocol coming in again to kind of make things a lot easier. With Bob Stake, we have like a bunch of different distribution channels hooked in already. So the latest announcements will be Xverse, for example, are plugged in. So you can go to one of their latest earn campaign and use Bob Stake under the hood to automatically deposit your Bitcoin directly from the Xverse wallet into one of the supported protocols. So Bob Stake is sort of this middle layer then between these providers, like Xverse, for example, and hopefully other wallets in the future. And then we back it onto all the LSTs on Bitcoin. So one of the most popular we have at the moment, I think that makes up quite a lot of the TVL on Bob, is SolveBTC. So SolveBTC.bbn are a Bitcoin LST where their Bitcoin is held by Babylon, and they feed those rewards back to the users. Bob Stake is very simple on the front end, as I mentioned. Like Xverse will have something very similar to this in their wallet UI in their campaign next week. And you simply just deposit Bitcoin into that, and you sign one single Bitcoin transaction. This is what I mentioned with regard to the UX. We wanted to avoid users having to sign EVM transactions and doing unfamiliar stuff, which is great because then if you're like a Ledger user, for example, you don't use any web wallets, you can do the same as well. You connect up your Ledger. You basically ascribe to the intent in the up return of that transaction. So this is where you do all the fun stuff. And they don't need to mess around with EVM signing, EVM wallets. Although one of the new features we're looking into is working with wallet providers like Dynamic. And if you don't know Dynamic, they've some cool stuff in the back end to generate EVM wallets from Bitcoin wallets. So what we're hoping in the future is we can help users that want to do more stuff after they do the initial kind of intent swap into kind of doing more interesting activities without having to like download a new wallet and set up keys and manage that, etc. Next slide, please. And this, yeah, sorry, I got a bunch of slides here, sort of repeating the same pitch. But yeah, users coming in through their wallet, it sends to the solver. They do the interesting stuff on chain with regard to this commitment in the up return. That's validated there, and if for example there was a malicious transaction there, that wouldn't get included. And then they can do the staking and all the fun stuff. Yeah, I think that's all just to say on that. So I wasn't sure what the vibe was here. It's the Hacker House, I assume, so I thought I'd add a couple of slides on like what we're looking into now with integrations with partners and users. So I can kind of just quickly go into that. And this is the lower level side of what I was discussing. So Bob Gateway is this we saw the slide before, it's sort of this middle layer between all these distribution channels, all these backends, but we handle that. You integrate Bob Gateway into like your front end and your back end. You can do all the fun stuff and you have access to lots of liquidity and tooling from other projects. So there's two sides to this. If you go back, one slide. The first side is the front end. So this is where I discussed like Xverse, for example. What you can do is if you have a website that you want to automatically show your users all the possible ways they can lock their BTC and earn money on it, which is what we do if you go to our app right now. If you go to app.gobob.xyz/stake, we use exactly this. It lists all the earning possibilities for your Bitcoin that you can lock into immediately, like Bedrock or Solve or one of our supported lending markets. And with this, like it's sort of like a two-step process where for the user then in your front-end integration, it's very similar, I think, to the Swing SDK. We modeled it after that, so it's like a DEX swap. You get your quote, what the best route is into, where you supply sort of the intended output token. Like say I wanted to supply BTC and get sold BTC.BBN. In these quote parameters, I just specify the destination token as sold BTC.BBN. And our complex logic under the hood would route that and find the best way for you to get one-to-one Bitcoin to sold BTC.BBN and lock that in. And then you sign a transaction using your Bitcoin wallet on the integration, and then start the order, and that's all done. And I think so for front ends, it's like this is all the code you really need to integrate. There's a couple other methods where you can use like list or the I don't know if anyone's used a lot of these like other Vault applications where you can see like all the positions you could lock your liquidity in. Basically the same interface, and you have like a get strategies call, I think, where it would just list that. And then the other thing we can implement is the back end. So going back to like a slide far before, the front end was the side here with Xverse. We had this other side where we had all the protocols, and that's where we see a lot of participation from hackathons where they want to integrate. So if we go to the next slide, we'll see we also have some integration code that we can use to integrate with Bob Gateway. This bit at the top is just explaining, again, what like that integration would look like. The whole flow of Bob Stake, Bob Gateway is that all the user does is send their Bitcoin to an address. What happens in the back end is we have this relayer service or this intent network that verifies the BTC was sent to the right address, that it was sent with the correct intent in this op return. On-chain then, there's the gateway contracts. They unlock the wrapped token. This is part of the atomic swap. And then they do this additional integration called a strategy. And how we've defined it, I think it's very similar to a cross, if anyone's used it, the cross-chain intents network, but they have a very similar interface. We've deemed, called strategy. For anyone who has a protocol on Bob and they were like, hey, I want inbounds of WBTC or inbounds of TBTC or some Bitcoin wrap token, and I want to do something interesting with it. So a very simple implementation of this would be to define this for like an Aave deployment, for example. You wrap that in the interface and handle gateway message. All you do is take the WBTC, you lock it in one of the Aave lending markets, you take the receipt token, and you send it back to the user. It's just super simple. It's quite flexible. We have this extra message at the end that you can do to encode additional arguments. We, for example, use it for slippage if we're conducting a trade, and which may take multiple blocks. The user may say, well, I realize the Bitcoin block is not going to be included for at least 10 minutes. A lot can happen in 10 minutes. They can specify additional arguments that prevent anything malaligned happening down the road. So it's pretty generic, but I think suffices for a lot of the use cases we've seen. And this is the last slide. If anyone has any questions, how like they want to build something on Bob, we're also at the Encode Hackathon just now, where we have prizes. So if you get on over there, I think we're hosting that all week. There's also prizes. I don't think we have any prizes here, but if you have any questions, please come over and speak to me.